Hello my friends, and welcome back to the You Can Do TV channel. The sisal fiber decorticator is a specialized machine designed for extracting fibers from sisal leaves efficiently. Sisal plants produce long, durable fibers used in rope, mats, and various industrial applications. The decorticator works by mechanically stripping the fleshy parts of the leaves, leaving behind the strong sisal fibers. This process, known as decortication, significantly reduces manual labor compared to traditional hand-stripping methods. The machine features adjustable rollers and blades to accommodate different leaf sizes and optimize fiber quality. With high throughput capacity and consistent output, the sisal decorticator enhances productivity and fiber quality, making it an essential tool in the sisal processing industry. Its design also minimizes fiber damage, ensuring superior strength and durability for end products. The Chop King Banana Tree Shredder is a specialized agricultural machine designed for post-harvest field cleanup and organic waste recycling. Built with a high-torque cutting rotor and heavy-duty steel blades, it efficiently shreds banana and papaya stems into fine, manageable pieces. This not only clears the field quickly, but also facilitates faster decomposition, transforming crop residue into valuable organic fertilizer. The machine's wide feed inlet accommodates large stems, while its robust frame ensures stability during continuous operation. Powered by a reliable diesel or PTO drive system, the Chop King delivers consistent performance across varied field conditions. Ideal for sustainable farming, it reduces labor costs, improves soil health, and supports eco-friendly agricultural practices. The Revo Pauma 4WD apple harvester offers high versatility for multiple orchard tasks, including pruning, tree tying, thinning, and harvesting apples and plums. Its integrated systems allow a single operator to perform quality control, weighing, and tray stacking, enhancing operational efficiency while minimizing fruit damage. The machine supports rapid bin changeover within 20 seconds and benefits from prompt maintenance response and readily available spare parts stocked. Equipped with advanced features such as autonomous driving, auto steering, and self-leveling, the Revo Pauma ensures precise maneuverability and consistent performance across varied terrain conditions. The Zurich 8D6 Dual demo showcases the powerful capabilities of this advanced agricultural machine. Designed for efficient field operations, the 8D6 Dual features dual engines that provide enhanced power and reliability. Its robust construction allows it to handle tough terrain and heavy workloads with ease. Equipped with modern controls and precision technology, the machine ensures optimal performance and fuel efficiency. The demo highlights its versatility in tasks such as tilling, planting, and harvesting, making it an indispensable tool for large-scale farming. Overall, the Zurich 8D6 Dual combines strength, durability, and advanced features to boost agricultural productivity. Grimmie machines are renowned for their versatility, capable of handling not only beets and potatoes, but also other root crops like celeriac. Featured here is the robust front mulcher FM300, designed to prepare the field efficiently by clearing residues and optimizing soil conditions. Following this is the trailed harvester, the ROOTSTER 604, expertly engineered for gentle and efficient lifting of celeriac roots. Alongside it, the self-propelled MAXTRON 620 offers high-performance harvesting with advanced technology and operator comfort. Completing the lineup is the CleanLoader field loading station, which streamlines the collection and transport process, minimizing crop loss and maintaining quality. Together, these machines ensure a seamless, efficient, and high-quality harvest, adapting effortlessly to varying field conditions and crop demands. NEXAT Next Revolution is the world's first holistic crop production system, featuring a powerful widespan carrier vehicle with interchangeable implements. Designed for tillage, sowing, plant protection, and harvesting, its modular attachments can be swapped by one person in under 10 minutes, with full automation planned. Currently powered by two 550 HP diesel engines, the system is ready for green hydrogen fuel cells. Each module's weight transfers onto the carrier, optimizing it into a self-propelled machine, improving guidance and reducing fuel consumption and CO2 emissions. The harvesting module increases throughput by over 50% compared to traditional combines and offers uniform straw distribution, enabling controlled traffic farming year-round. The widespan controlled traffic method cultivates fields 6 to 24 meters wide, protecting soil and maximizing yield potential. A tractor performs flame weeding, an agricultural technique using controlled flames to eliminate weeds without chemicals, promoting eco-friendly farming and preserving soil health. The Breil Meer Motormar is a versatile machine designed for efficient slurry spreading across agricultural fields. Equipped with powerful motors and precision controls, this mower not only cuts grass but also evenly distributes liquid manure, ensuring optimal fertilization. Its robust construction allows it to operate effectively on uneven terrain, improving soil health and crop yields. The slurry spreading system is carefully engineered to prevent clogging and maintain a consistent flow rate, enhancing nutrient distribution. Ideal for farmers seeking to combine mowing and fertilizing in one operation, the Breil Meer Motormar increases productivity while reducing labor and time. Easy to operate and maintain, it represents an innovative solution for modern sustainable agriculture, helping to boost efficiency and promote environmental stewardship. The OE 4.5 FRUMACO Shake and Catch Harvester uses a unique continuous harvesting system. Equipped with a continuously operating shaker, it harvests trees without stopping. A special electro-hydraulic mechanism controls the process, ensuring fruits do not fall to the ground by using an umbrella over tree rows. Fruits are collected through a sealed central conveyor belt, enabling uninterrupted harvesting despite fruit density. The machine's high chassis, with controlled lateral suspension, allows adaptation to challenging terrain. Fruits are transported via conveyors and elevators to a powered container in an adjacent row. The operator controls all functions from the cabin. All operations, including collection adjustments during transport, are electrohydraulic and TA. The Euroagromat AP160, with an overall width of 1.60 meters and a working width of 1.45 meters, sweet potato harvester is designed to lift tubers to the surface without damage. It features two 420mm discs for vine cutting, a lifting blade that slides beneath the tubers, and a vibrating sieve powered by a crankshaft via the gearbox. A hydraulic cylinder adjusts the sieve's inclination, ensuring it stays level when engaging the ridge. The blade guides soil and tubers onto the sieve, which gently shakes to separate them. The CMC Street 300, the world's best-selling tractor-pulled compost turner. With a 3 meters rotor and 3.4 meters working width, it delivers up to 1,000 cubic meters per hour throughput. Optimized and compact, it meets controlled microbial composting standards and is road legal for easy transport. The Grimmie GH8 is an 8-row ridging hiller, designed for use with row spacings between 75 and 91.4 centimeters. Engineered to deliver optimal ridging performance, this versatile machine can be customized with a variety of tine options to suit different soil conditions. Whether working in light sandy soils or heavier clay-rich fields, the GH8 adapts to ensure precise and effective hill formation. Its robust construction guarantees durability and consistent results across diverse environments. With its adjustable settings and adaptable tools, the GH8 enables farmers to maintain perfect ridges that promote healthy crop growth and facilitate efficient irrigation and harvesting. This combination of flexibility and reliability makes the Grimmie GH8 an essential implement for modern, productive farming. The EAM Misano RSHM 145 stone barrier is specially designed for use with microtractors like the Iseki series. With a working width of 1.45 meters, it efficiently buries stones, clods, and debris beneath a fine soil layer, creating an ideal seedbed. Its reverse rotation rotor, equipped with hardened blades, lifts and screens the soil, depositing the finer fraction on top. Compact yet powerful, the RSHM 145 ensures excellent results in horticulture, landscaping, and vineyard preparation, even in stony or uneven terrain. The Grimmie VARITRON 470 is a powerful, self-propelled potato harvester designed for 4-row harvesting with exceptional efficiency and flexibility. Equipped with a highly adaptable range of separation devices, the VARITRON 470 expertly handles varying soil and crop conditions to ensure clean, high-quality tuber recovery. Its non-stop bunker holds up to 7 tons of potatoes, featuring a continuously circulating bunker belt that maximizes loading capacity at all times, reducing downtime and improving productivity. The harvesting process is supported by a variety of automated functions, which can be conveniently controlled from the optional premium comfort cabin. This advanced control system offers operators maximum ease and precision, even in challenging field conditions. Combining robust engineering with intelligent automation, the VARITRON 470 delivers outstanding performance, making it an ideal choice for large-scale potato growers seeking reliable and efficient harvest solutions. Whether in light or heavy soils, this harvester ensures a smooth, continuous operation that optimizes yield and minimizes crop damage, supporting the highest standards in modern agriculture.
On March 16th, Keltbray's decommissioning team made history with the explosive demolition of a towering 73 meters gas holder at Tees Works. This high-impact operation, executed with precision, was a thrilling collaboration with explosive experts PDC and engineering specialists Wentworth House Partnership, who ensured every detail met the highest safety standards. The controlled collapse was a testament to cutting-edge engineering and teamwork, another landmark step in transforming Tees Works into a hub of innovation. Fire! On August 22nd, Ferry Bridge C Power Station in West Yorkshire witnessed a spectacular demolition as Keltbray brought down two towering chimney stacks, the massive boiler house and the bunker bay in one epic blowdown. Crowds gathered to watch history crumble in a cloud of dust, marking another milestone in the site's transformation. The controlled explosion was a breathtaking display of engineering precision, shaking the ground and clearing the skyline in mere seconds. What a thrilling moment. The blowdown of Eggborough Power Station's cooling towers was a meticulously planned demolition executed by DSM Demolition, with explosives handled by Specialist Explosive Services. The process involved two key phases: preparation and controlled detonation. In Phase 1, engineers cleared internal structures by removing diagonal columns and lower wall sections to allow machinery access. They stripped out the grillage system that once facilitated cooling. Phase 2 involved pre-weakening the towers using test blasts to determine the optimal amount of explosives required for structural collapse. Since the towers had been reinforced with grout and mesh, these tests ensured a safe and effective blowdown. Demolition of old silos is a complex and hazardous process requiring careful planning, specialized equipment, and strict adherence to safety regulations. Silos, often made of reinforced concrete or steel, store bulk materials such as grain, cement, or coal. Over time, structural deterioration due to weathering, corrosion, or prolonged use can make these structures unstable, posing significant risks to workers and surrounding areas. Many old silos suffer from weakened foundations, cracks, and material fatigue. This instability can lead to unpredictable collapses, endangering workers and nearby buildings. According to OSHA, Occupational Safety and Health Administration, structural collapses account for nearly 30% of all demolition-related fatalities. Demolition produces large amounts of debris and dust, which can cause respiratory issues, eye injuries, and other health problems. Silica dust from concrete silos poses a severe hazard, potentially leading to lung diseases such as silicosis. Workers often need to enter silos to assess structural integrity or place explosives, exposing them to suffocation, toxic gases, or engulfment hazards. Statistics from the National Institute for Occupational Safety and Health, NIOSH, indicate that over 50% of confined space fatalities occur due to a lack of proper ventilation and safety protocols. Dust accumulation in grain or cement silos can create explosive atmospheres. A single spark from cutting equipment or static electricity can trigger a devastating explosion. Studies show that grain dust explosions occur in the U.S. approximately 10 times per year, resulting in injuries and fatalities. The use of heavy machinery such as excavators, wrecking balls, or controlled explosives increases the risk of accidents if not operated correctly. Reports suggest that nearly 20% of demolition accidents involve machinery-related incidents.
I'm gonna try and pull it down by the ladder.
Comprehensive structural assessment. Engineers must conduct detailed inspections to determine the safest demolition method. Controlled demolition techniques. Depending on location and structural conditions, methods such as top-down dismantling, implosion, or mechanical demolition should be chosen carefully. Use of personal protective equipment, PPE. Workers must wear helmets, respirators, gloves, and reinforced safety boots. Proper dust control measures. Water suppression systems and ventilation should be used to minimize airborne dust hazards.
She's not moving. There she goes.
Emergency preparedness plans. Clear evacuation routes, medical response teams, and contingency plans must be in place.
There we go.
High-reach excavators are among the most commonly used machines in high-rise demolition. Equipped with hydraulic shears, crushers, and breakers, these machines can efficiently dismantle structures from top to bottom. Some of the largest high-reach excavators can extend up to 55 meters, 180 feet. This approach reduces the risk to workers and helps control the spread of dust and debris. This section is about the demolition of the 1950s Holy Rosary Hospital in Miles City, Montana. After being vacated in 1995, the 5-story structure required specialized equipment for its removal. A demolition crew, led by John Mugley Construction, utilized a machine equipped with cement-crushing jaws attached to a 6-story arm to break down the building efficiently. The process began with site preparation, including securing the area and removing hazardous materials. Structural weakening followed, where non-load-bearing walls and interior elements were dismantled to prevent uncontrolled collapse. Heavy machinery systematically tore down the main structure, starting from the top and working downward. Debris was sorted for disposal and recycling, with concrete being crushed for potential reuse. Dust control measures, such as water spraying, were implemented to minimize airborne particles. The final phase involved clearing the site, ensuring proper waste management, and preparing the ground for future construction. The month-long demolition paved the way for the Miles City Housing Authority's restoration project, transforming the area into affordable family apartments. The deconstruction of Battersea Power Station's massive roof structures in turbine halls A and B was a highly coordinated process undertaken by Celtbray Demolition and Civil Engineering. The demolition began with the installation of temporary steel platforms using the existing gantry crane rails. These platforms, 6 in total, were rigorously tested to support up to 60 tons and allowed for systematic removal of structural elements. To contain debris, Celtbray constructed a scaffold birdcage crash deck beneath the roof. The concrete roof slab, 225 millimeters thick and supported by steel trusses spanning 25 meters, was divided into 480 sections. Each section, measuring 2.5 x 3.75 meters and weighing approximately 5 tons, was lifted out by site tower cranes. Temporary lifting frames were installed on the underside and top of each slab to facilitate controlled removal. The extracted sections were processed on-site before being sent for recycling. A team of 20 completed the demolition of Turbine Hall A's roof in 14 weeks. Simultaneously, an enclosure was erected above Turbine Hall B for asbestos removal, a process managed by Keltbray Environmental Solutions over 3 years. In Turbine Hall B, 14 steel trusses, each weighing 18 tons, were dismantled over 2 weekends. Each truss was secured before removal, with cutting performed by specialist personnel working in tandem at either end. The lifting operations, designed for twice the actual weight, were monitored using wall sensors to ensure structural stability. Throughout the project, workers utilized respiratory protection, subjected to regular medical checks. The methodical execution ensured safety, efficiency, and minimal environmental impact while preserving key elements of the historic structure. Get ready for a mind-blowing moment. On December 11th, at exactly 2 p.m., the colossal Sinteranlage in Duisburg met its dramatic end through an astonishing controlled demolition. The Thüringer Sprenggesellschaft unleashed their expertise, using precision explosives to topple the steel titan from the old Ruhrort works. Imagine the scene. 5,000 tons of steel crashing down in seconds, all orchestrated with surgical accuracy. They rigged the structure with carefully placed charges, targeting key supports to ensure a flawless collapse. The tools? High-grade dynamite and cutting-edge timing devices, detonated in a symphony of destruction that echoed far beyond the city. Built in 1957 and dormant since 1983, this industrial giant didn't stand a chance against such a masterful method. What a thrilling way to erase history and make room for something new. The Moros HP 110 shear at Bradford Waste Traders is a powerhouse in scrap car processing, transforming end-of-life vehicles into neatly compressed, recyclable metal with sheer force and precision. The process is nothing short of jaw-dropping. Watching it work is like witnessing industrial might in action. First, the car is placed onto the shear's heavy-duty loading table, where a powerful hydraulic ram forces it into position. Then comes the real spectacle. The massive cutting blades descend with relentless force, slicing through the car's frame like a hot knife through butter. Metal creaks, glass shatters, and in seconds, what was once a fully assembled car is now reduced to manageable chunks of steel. The HP 110 doesn't just cut, it compacts and conquers. Its hydraulic press compresses the remaining metal, squeezing it into dense, high-quality scrap, ready for the next stage of recycling. This isn't just destruction, it's precision engineering at its finest. Every crushed panel, every cut section means valuable metal is being salvaged for future use. In minutes, a vehicle that once roared down the streets is transformed into raw material, destined to be reborn in new cars, construction materials, or machinery. It's an industrial ballet of power and efficiency, brutal yet mesmerizing, turning waste into wealth with each mighty stroke of the Moros HP 110 shear. The Stronken killer rips tree stumps from the ground with sheer force and precision. Once positioned, its massive hydraulic arms spread wide, gripping the stump with an unstoppable closing force, up to 500 kilonewtons. As pressure builds, roots snap, and the stump breaks free from the earth. The 360 degrees rotation system ensures perfect positioning, attacking from any angle for maximum efficiency. With high-pressure hydraulics, up to 320 bars and 160 L per minute flow, this machine works fast and aggressively, tearing through even the toughest stumps. Built from wear-resistant steel, it withstands extreme forces with minimal maintenance. Compatible with multiple coupler systems like S-System, Atlas SMP, and Lenhoff, it adapts easily. Need even more control? Mounted on a tilt rotator for ultimate flexibility. The Stronken Killer doesn't just remove stumps, it dominates them. You're watching the demolition of the temporary supports of the Grumpental Bridge on November 8th. 8 temporary supports ranging from 20 to 60 meters in height and totaling 1,800 cubic meters of concrete were removed using 100 kilograms of explosives. The process involved drilling 1,000 holes to ensure controlled detonation. The supports collapsed sequentially in a controlled manner, confirming the stability of the self-supporting bridge structure. Post-demolition, 150 tons of steel and concrete debris required removal. The operation marked a key milestone in the construction of the high-speed railway line between Ebensfeld and Erfurt, ensuring the bridge's readiness for final construction phases. Track removal process at Zurich Central Station. In the summer, extensive track renewal work was carried out at Zurich Central Station, one of the city's busiest transport hubs. Years of heavy use had significantly worn down the tram tracks, requiring a complete replacement. Additionally, adjustments were made to the track layout, including widening the curves to allow trams to navigate turns more efficiently. The project began with the removal of approximately 2,500 cubic meters of asphalt and concrete, equivalent to 167 truckloads. This material was transported to a recycling facility. Excavation reached a depth of 70 centimeters to prepare a stable foundation. A geotextile layer was placed at the base, followed by a gravel bed that accommodated new utility lines, drainage systems, and technical infrastructure. Once the groundwork was completed, new tracks were laid, aligned, and welded. Most welding took place at night to minimize disruption, with 171 welds executed during the first weekend alone. After track installation, a sublayer of concrete was poured to stabilize the rails. This was followed by additional concrete layers to form the final track bed, after which the road surface was restored. Alongside the track renewal, tram stop platforms were widened and extended to accommodate longer trams, improving passenger capacity. However, due to limited space, the tracks could not be fully straightened. As a result, the project required a special exemption from accessibility regulations. Testing of the new tracks and tram routes was conducted before resuming service. The first trams operated on August 13th, while the entire project, including final surface work, was completed by the end of October. With these upgrades, Zurich Central Station's tram network was modernized to enhance efficiency, durability, and passenger experience, ensuring smoother operations for the future.
The coke production process at OKK Koksavny begins with the selection and preparation of raw materials, primarily coal, which is carefully chosen to meet low ash content and specific physical properties. The coal is then loaded into coke ovens, where the carbonization process occurs in an oxygen-deficient environment at temperatures ranging from 900 degrees Celsius to 1,100 degrees Celsius, removing volatile components and transforming the coal into high-carbon coke. After carbonization, the hot coke is cooled using water spray or in cooling tanks, bringing its temperature down to below 100 degrees Celsius. The coke is then inspected and sorted according to quality standards, with any substandard products being discarded or reprocessed. Throughout the process, byproducts such as coke oven gas, coal tar, and ammonia are recovered and reused, optimizing production efficiency and minimizing environmental impact. The entire coke production process at OKK Koksavny ensures high quality while strictly adhering to safety and environmental standards. First, a large steel ingot is heated in a furnace to the forging temperature, typically between 1100 to 1200 degrees Celsius, to achieve optimal malleability for processing. Once heated, the ingot is transferred to the hydraulic press for upsetting. The ingot is compressed with significant force from the ram to reduce its height and increase its width, providing a preliminary shape. Next, the forging tools or anvils are swapped to match the desired shape. The elongation process then follows. The ingot is further pressed and stretched lengthwise under the hydraulic press's force, often with the aid of a control system to ensure precision and uniformity. If the ingot cools and loses its malleability during this process, it is returned to the furnace for reheating, maintaining a high enough temperature for subsequent forging steps. Nissan in the UK is accelerating its production with the help of AP&T at the Sunderland plant, where the Qashqai models are manufactured. The automated tandem line from AP&T at this plant has the capacity to produce 14,000 parts per day. It includes 4 fully automated presses equipped with a destacker and 10 speed feeders, along with AP&T's high-speed performance robots. The die change can be completed within minutes of operation, ensuring minimal downtime. Additionally, the change of AP&T grippers is easily carried out. This advanced automation system significantly enhances the production efficiency of various parts for Nissan vehicles. During the production process, the automated system ensures a seamless workflow, maintaining high levels of productivity. The plant's automation capabilities not only streamline production, but also allow for quick adjustments, such as tool changes, ensuring that the assembly line operates smoothly and meets production targets. With these innovations, the Sunderland plant has been able to increase its output, improve overall efficiency, and help Nissan stay competitive in the automotive market.
The demolition of the Nipagon River Bridge was a complex and highly technical operation requiring precision and innovation. Given its span of 827 feet, 252 meters, and its position 100 feet above the water, conventional dismantling methods were not feasible. Instead, a carefully planned process was implemented to ensure safety, environmental protection, and efficiency. To begin, access holes were cut into the bridge deck to allow the placement of hydraulic jacks and rollers underneath. These rollers, each capable of supporting 100 tons, were positioned strategically to facilitate the gradual movement of the bridge. 8 of the rollers were equipped with hydraulic gearboxes to provide controlled propulsion. As an additional precaution, a cable system was installed to stabilize the bridge while it was being shifted. One of the key challenges was ensuring that the structure remained balanced throughout the process. The king post and cables played a crucial role in maintaining stability, preventing any uncontrolled shifts that could result in collapse. The team meticulously calculated every kilogram of weight on both ends of the bridge to avoid any structural failure. The demolition proceeded in stages. Initially, the overhangs were removed, starting with the western section. On the eastern side, both the overhangs and deck sections were dismantled. An aluminum slurry containment platform was installed beneath the bridge to prevent debris from falling into the Nipagon River, a critical environmental measure given the waterway's significance as the largest tributary to Lake Superior. With the preliminary dismantling completed, the focus shifted to rolling the bridge off its original position. The movement began in early March 2016, with the team advancing the structure incrementally. The process required constant adjustments, as sections of decking were removed to maintain balance. A Link-Belt 460 excavator was used to assist in weight distribution and ongoing dismantling efforts. As the bridge moved westward, teams worked simultaneously to torch-cut sections of steel and remove them. Precision was essential in cutting the girders, ensuring that each section was detached in a controlled manner. Heavy machinery was then used to lift and transport the severed sections away from the site. Despite cold weather and operational challenges, the demolition proceeded smoothly. The bridge advanced approximately 140 feet in the initial phase, with the goal of reaching 270 feet by the end of the process. Section by section, the massive steel structure was dismantled, clearing the way for the final construction of the new 4-lane cable-stayed bridge.
Production process of H-beam steel involves several key steps. First, the raw steel materials are cut into the required lengths. These pieces are then assembled into the shape of an H-beam, ensuring proper alignment. Submerged arc welding is applied to securely join the components, providing strong and high-quality welds. For finer, more intricate welding tasks, gas welding is used. Kennametal offers a comprehensive and efficient solution for turbine blade machining, with a variety of tools tailored for different machining operations. Utilizing standard Kennametal tools like the Harvey IITM and KCPM15, manufacturers can achieve high precision and optimal performance in machining turbine blades made from materials such as M1.4923X 22CR MOV 12.1. The Harvey IITM tool provides exceptional cutting capabilities with parameters such as AP equals 0.7 mm and AE equals 4 mm for roughing and finishing, while the Dodica Mini TM tool is suited for high-feed machining with AP equals 3.5 mm and AE equals 38 mm. For general-purpose end milling, tools like the KCPM15 are ideal for a wide range of applications, providing reliable results with AP values from 0.5 mm to 2 mm, and AE from 0.5 mm to 1.5 mm. Additionally, the KC725M end mill ensures excellent material removal rates, suitable for larger-scale operations with AP equals 0.8 mm and AE equals 5.7 mm. Kennametal also offers solid carbide drills, KC7315, for precise hole-making, designed for materials with a hardness like M1.4923x22 CRMOV 12.1. Overall, Kennametal's advanced tooling solutions support turbine blade manufacturing with high-speed, high-feed capabilities, ensuring consistent quality and precision throughout the machining process. Kennametal's MaxiMet carbide end mills are designed for high metal removal rates and superior surface finishes, particularly in aluminum. Models like ABDE1600A3AS and ABDE0625J3AS feature a 5/8 diameter and a 38 degrees helix angle, offering cutting speeds up to 500 meters per minute, 1640 SFM, with a feed per tooth of 0.12 millimeters, 0.0047 IPT, and cutting depth up to 12 millimeters. Smaller variants, such as ABDE0800A3AS, offer cutting speeds of 250 meters per minute, 820 SFM, and are ideal for precise machining. Flow forming process, also known as spin forming or tube spinning, is an advanced method for manufacturing thin-walled, high-precision metal tubular components. Initially, a short metal preform, typically made of aluminum, steel, or titanium, is securely mounted onto the spindle of the machine. The preform is then rotated at high speed, while hydraulic or mechanical rollers move along its surface, gradually pressing and stretching it to elongate and thin the tube wall. The wall thickness is precisely controlled by the roller's applied force, achieving an impressive accuracy of plus or minus 0.05 millimeters. The BendMac PRO 100/120 angle rolls are strong and reliable with their Street 52 weld construction body. Minimum flexion causes less deformation by the help of their machine's enlarged roll diameters. By the help of big measurements of bearings, durability and high bending momentum can be obtained. The power of hydraulic cylinders enables to bend the larger parts without difficulty. Practical and universal rollers creates the possibility of easiness for bending various sections, and this feature gives the opportunity of being more powerful and robust. BendMac profile bending machines are 3 rolls driven. This feature allows to have a possibility to make the high-capacity bending processes real. Secondly, our 3 rolls driven machine minimizes the slipping of the materials during the bending process. The production process for glass-lined equipment involves several key stages to ensure its durability and functionality. It begins with cutting and rolling the materials to the required shapes. Next, the components undergo welding, which includes welding the manhole cover, punching necessary holes, welding nozzles, and joining the body and head with connection rings. After welding, the parts are ground for smoothness and thoroughly inspected. The carbon steel body is then pre-fired, repaired if necessary, and coated with a ground lining. Following this, the equipment is placed in a furnace for firing to bond the lining, and then undergoes a second round of surface coating, lining, and final firing. The glass lining is then completed, and a spark test is conducted to ensure its integrity. Once the glass lining is confirmed to be in perfect condition, the equipment is painted for protection and aesthetic purposes. The cement production process involves continuous quality monitoring through laboratories at the Cemex Prakovice plant. In the lab, samples are homogenized and analyzed for moisture, setting time, and volume expansion. Test specimens are created to determine strength according to standards. A mixture of cement, sand, and water is prepared in a mixer and placed in a mold, then compacted on a vibrating table and stored in a humid chamber for 24 hours. The density of the paste is measured before testing, and the sample is placed in an automatic VICAT apparatus to evaluate setting time. After 24 hours, test specimens are removed, demolded, weighed, and tested for strength. Each specimen undergoes bending and compressive strength tests, and results are recorded in the laboratory information system. In the X-ray lab, raw materials like clinker and cement are analyzed, with daily chemical analysis of various materials. The analytical lab tests for hexavalent chromium, free lime, and other components in cement, while the AFR lab checks fuel quality, including calorific value, and the content of chlorine, sulfur, and fluorine. The spring manufacturing process at FWG IHW Federn GmbH not only follows standard production steps, but also stands out thanks to its proprietary technological innovations that enhance efficiency and product precision. First, the raw material is heated using induction technology, a unique feature of FWG's manufacturing process. With the help of a special induction furnace, each steel bar is heated to over 800 degrees Celsius within just a few minutes. This method eliminates long waiting times typically associated with conventional walking beam furnaces and allows for quick transitions between different wire sizes, increasing production flexibility. After heating, the steel bar is coiled into spring shapes according to design specifications. Then, the spring ends are machined mechanically using a special turning process, which is patented and exclusive to FWG IHW. This method enables springs to achieve significantly higher precision and length, as well as in tolerances E1 and E2, ensuring superior quality and consistency during operation. By combining advanced induction heating with high-precision end machining, FWG IHW Federn GmbH has established a strong technological advantage in the technical spring manufacturing industry. The process of glass melting involves several steps. First, glass waste, cullet, is used, and the furnace is loaded at a temperature of 1,370 degrees Celsius, with the melting temperature set at 1,410 degrees Celsius. The glass mixture is composed of a silica-based glass batch and potash. The glass is then clarified using a physical method that involves the decomposition of organic substances in the glass. For this, a steel rod is inserted with wet wood, apples, beets, potatoes, or other organic materials and submerged into the lower layers of the molten glass. The large bubbles formed during this process absorb smaller bubbles, rising to the surface where they burst. Lead crystal is prepared by melting glass sand with potash, potassium carbonate, and lead oxides. The HAEUSLER-HPR Universal Section Bending Machine is a high-performance solution tailored for tunnel mining and heavy industrial applications. It features a powerful 3-roll bending system capable of shaping tubes, beams, and custom profiles with precision. Its large diameter bending rolls are mounted in permanently lubricated spherical roller bearings, ensuring cost-effective, maintenance-free operation. The HPR offers exceptional flexibility, supporting multi-head shaft production and complex profile forming from strip or coil in a single pass. Hydraulic adjustment of pressure roller supports in 3 directions. Conveniently controlled from the operator panel, enhances ease of use. Vidco Foundry's cylinder casting department specializes in producing rolling mill shafts using centrifugal casting technology licensed by Gonterman Pipers. With an annual production of 6,000 to 7,000 tons, the department manufactures shafts from materials such as high chromium cast iron, tool steel, and ductile iron, continually improving to meet market demands. Additionally, the foundry produces shaped castings for industries like energy, mechanical engineering, and mining, with a focus on high quality, precise dimensions, and timely delivery. They also use centrifugal casting for brass rings and other non-ferrous metal products. Bending in Connell, a high-performance alloy with excellent heat and corrosion resistance, involves several steps to ensure accuracy and structural integrity. The first step is material preparation, where Inconel tubing is selected based on specifications such as diameter, wall thickness, and length. This alloy is often used in high-temperature environments, so the material must be thoroughly tested for quality. Next, the Inconel tubing is fed into a die to maintain its shape and prevent the tube from collapsing. During the bending process, the tube is placed in a manual or CNC bending machine, depending on the complexity and precision required. CNC machines are often used to achieve higher precision, especially when performing complex bends. Bending is done slowly and carefully, using a bending die to create the necessary angles and curves, avoiding stress or distortion that would reduce the strength of the material. Zeman is one of the leading companies providing complete steel fabrication solutions, from design to production, thanks to the application of advanced automation technology such as the Steel Beam Assembler (SBA) system. The process begins with the import of data from CAD drawings into Profit software, allowing automatic programming of machining steps without manual intervention. Raw steel, such as HEA beams, IPE, or steel plates, is precisely cut using CNC plasma or laser machines, ensuring minimal errors. Next, the SBA line automatically assembles details such as column base plates, stiffeners, or connecting plates. The material handling robot, capable of lifting steel plates weighing up to 200 kilograms, uses laser sensors to locate and place accessories from the add-on parts warehouse with an accuracy of 1 millimeter over a length of 18 meters. After changing the tool, the welding robot performs tack welding to fix it, then completes welding using MIG/MAG technology, ensuring even, durable welds on all four sides thanks to the integrated rotation system. The average speed is 1.5 minutes per part, superior to manual methods. After assembly, the steel structure is quality checked by ultrasound or magnetism, ensuring no defects. The steel surface is sandblasted, anti-corrosion painted or galvanized, suitable for harsh environments such as factories, bridges, or wind farms. The finished product is packaged and transported to the construction site, ready for assembly. Zeman not only optimizes time and costs, but also minimizes material waste, meets European standards EN and high-volume production needs. This is the ideal solution for projects requiring high precision, speed, and durability in the steel structure industry. The assembly and welding process of the HEA 400 beam using Zeman's robots demonstrates advanced automation technology in structural steel processing. The HEA 400 beam is fed into the Steel Beam Assembler line, where the material handling robot uses laser sensors to precisely position and assemble details such as footplates and stiffeners with an error of only 1 millimeter over 18 meters. The welding robot then fixes the detail with spot welding, then completes the welding using an automatic rotation system, ensuring even welds on all four sides. Controlled by Profit software, the process achieves a speed of 1.5 minutes/detail, optimizing time and quality compared to manual methods. The column base assembly and welding process using the Z-Man Steel Beam Assembler (SBA) robot system is an advanced automation solution that optimizes the processing of structural steel. Based on the information maximum possible plate 200 kilograms, inserting from add-on parts, tool change, tack welding, the process is performed as follows. First, steel plates weighing up to 200 kilograms, such as column bases, are picked up by the material handling robot from the add-on parts warehouse using a magnet system or mechanical clamps. The laser scanning robot determines the exact position on the beam, then changes the tool to suit the process. Next, the welding robot performs tack welding to fix the base plate to the beam, ensuring high precision before finishing welding. The SBA system, with ProFit software, automates the entire process, achieving an average speed of 1.5 minutes per part, improving productivity and weld quality. MOB's CH120 CNC tube bending machine, 114.3 mm stainless steel, is an optimal solution for industries that require high-precision tube bending. This bender is distinguished by its rigidity, stability, and ability to work in harsh environments such as humidity and temperature extremes. The CH series covers a range from 10 mm to 420 mm OD, suitable for a wide range of tube manufacturing industries and applications. The Unison 100 features intelligent tube technology, offering a fast and efficient tool change process. The Unison Breeze 4-inch tube bender demonstrates how the tool change is completed in just 7 minutes, making it a quick and easy process. The steps begin with removing the tool post nut, followed by the removal of the clamp die, pressure die, wiper die, bend die, and collet insert. Next, new collet inserts are installed, along with the new pressure die, clamp die, and bend die. The process continues with the installation of new spacers into the tool post nut and the wiper die, followed by the insertion of the new mandrel and tie bars. This streamlined tool change process ensures minimal downtime, improving overall efficiency in tube bending operations. AT&T has supplied an advanced press hardening line installed at Great Wall Motors, enhancing their production capabilities. This state-of-the-art line is specifically designed for producing high-strength parts for automobile body in white. The system is equipped with advanced automation, streamlining the production process for superior precision and efficiency. The entire line is seamlessly integrated and operated from a single control panel, allowing for simplified control and monitoring. This technology from AT&T strengthens Great Wall Motors' manufacturing process, improving both the quality and productivity of their high-strength automotive components. The blanking line with cut-to-length shear, equipped with advanced automation from Schuler, ensures high efficiency throughout the production process. The line begins with threading high-strength blank material and trimming the first external coil section. The system includes a transition from dirty to clean rollers and homogenizes the coil sheet. A Precision 17 roller straightener ensures proper strip straightening, while loop adjustment and roll feed mechanisms provide smooth material handling. The strip is cleaned using a combination of suction and compressed air. Blanking is performed with a 4-column swiveling shear, which ensures precise straight-edge cutting and the production of rectangular blanks. The system also allows for easy changeover for processing the next blank, whether rectangular or trapezoidal. This efficient setup allows for continuous and reliable production with minimal downtime, making it suitable for high-volume blanking applications. The Z-Man soffit roll-forming machine operates by feeding steel coils through a series of precision-engineered rollers that gradually shape the material into soffit panels. This continuous process ensures high-dimensional accuracy and excellent surface quality. Designed for efficiency, the machine integrates punching units for vent holes and custom patterns during production. With automated roll changes and programmable controls, it allows for rapid profile adjustments to meet diverse architectural needs. Z-Man's robust engineering guarantees consistent output, making it ideal for large-scale soffit manufacturing with minimal manual intervention. A tractor is pulling an agricultural tillage tool, a soil cultivator. This is the McFarlane Quadratill, a primary tillage implement designed for crop soil preparation. Its functions include loosening the soil, mixing crop residues evenly, and leveling the ground surface. These actions help reduce erosion and create ideal seed beds for planting. The Quadratill is promoted as a one-pass tillage tool, saving time and effort compared to using multiple implements for soil preparation. It is especially effective in fields with heavy crop residue, such as continuous cornfields, making it a valuable tool for modern farming operations focused on efficiency and soil health. In the rugged, rocky soils of Corsica, the EAM Massano RSE 145 GD stone barrier demonstrates its exceptional performance. Designed for demanding conditions, this robust machine works at a width of 1.45 meters, efficiently burying stones, clods, and organic debris beneath a refined topsoil layer. Its heavy-duty rotor, equipped with hardened steel blades, rotates in reverse direction, lifting and screening the soil before depositing the finer fraction on top. Adjustable working depth and reinforced side panels ensure consistent results, even on terrain with high stone content. Ideal for preparing seed beds in horticulture, vineyards, and landscaping, the RSE 145 GD guarantees a smooth, rock-free surface ready for planting, while reducing the need for additional passes and improving soil structure in challenging environments. The dual 12 Gold EAM Chechi and Magli mini plug planter is a semi-automatic machine designed for planting tomato crops in 2 rows across 3 beds simultaneously. It features a 12-cup rotary distribution system operated by a single person for 2 planting lines. The inter-row spacing per unit is adjustable from 35 to 50 centimeters, with optional settings of 30/50ths or 26/50ths of a centimeter. The minimum distance between 2 planting elements is 70 centimeters, which can be reduced to 60 or 52 centimeters with options. The planter can handle between 5,000 to 7,000 plants per hour per operator. It also includes 6-sided rotating plant holders and a device to lay irrigation pipes, drip irrigation, along each bed, enhancing planting efficiency and precision.